All right, guys, this is example 5. They're asking you which point on the graph are closest to the points 0, 2. Okay, so if you think about it, if you were to draw a line from that point to the graph, you could see these lines with different lengths. And you notice that the graph is symmetric, right, about the y-axis. So you're gonna have 2 points. This point here is probably gonna have the same distance as this point, right? So it looks like this one's really large. It looks like this one's really large. So the answer is gonna fall somewhere in here. And that's the whole idea. Which point on the graphs are closest to the point 0, 2? Okay, we wanna get the shortest distance. And you guys kind of see that already. I'm just gonna put 1 to make it a little easier. All right. So we know the answer is somewhere in between 0 and 2. Now, to really get this, we need to kind of create a function for all those distances, right? And we actually have the distance formula. The distance formula, it's kind of like Pythagorean theorem if you look at it, right? It's just going to be the square root of x minus x1 squared plus y minus y1 squared. And you can label this like x2, y2 as well. But literally, you're just getting the distance between 2 points. You're getting the change in x. You're getting the change in y. And because it's Pythagorean theorem, you know that the change in x squared plus the change in y squared is equal to the hypotenuse or whatever, the distance squared. Okay? So when you have this formula, distance, you're just solving for d. Okay? That's the formula we're going to use, and that's where it comes from. Okay, I'm going to erase that because I don't have enough space to work on this. Now, if we look at this, you're asking yourself, well, what's my x1 and what's my y1? And that's just going to be that first point, okay? That's just going to be our first point. And what's your x value? Well, the distance you travel for x. That's going to be our x2, wherever that is, right? It's going to be there. It just depends on the point. It could be that one, it could be that one, and so forth. But our y value is the change in y's, right? Well, we have our 2, and then we have that change. As the graph continues, you're going to have a change in y, and that y distance is going to be given by our function. So the distance formula that we're going to be using is going to be the square root of x minus 0 squared plus our y value. That first y is going to be given by the function, okay? Because that literally tells us the rise, right? Tells us from that point what's our rise or what's our fall. So that y value is what's going to give us that change in y. So we're going to say 4 minus x squared minus 2, okay? And we're going to square that. And that's where that y value comes from the distance formula. Now we have our distance formula, and we're just going to simplify this to make it a little bit easier. This is going to become x squared plus 2 minus x squared squared. And if we simplify that further, we're going to end up getting x to the 4th minus 4x squared. Actually, after we simplify, it'll be minus 3x squared. Okay? 4x to the 4th minus 3x squared plus 4. Okay? So we have our function, and now we want to derive it. Some books are saying that you could kind of neglect the square root because the point is not going to be that different, to make it a little bit easier for yourself. But I'm not going to do that. I'm actually going to just solve it with the derivative. Okay, and the square root of a function, the derivative of a square root is going to be 1/2 times the square root of that function inside, right? Times the function itself, because we're doing chain rule. So that would be 4x cubed minus 6x, okay? And when we make the derivative equal to 0, pretty much when we multiply all the denominator, right, all this is going to cancel out. So you're just going to be left with 0 is equal to 4x cubed minus 6x. And if we factor this out, we could factor out a 2 and an x, and we're going to be left with 2x squared minus 3. So we have x is equal to 0, and after you solve this one, you're going to get x is equal to plus or minus the square root of 3 over 2, okay? So now we have our points, and again, we notice that because this is a symmetric function, that you should have 2 points. All right, you're gonna have 1 point here, and you're gonna have 1 point there. So that goes with 1x, and that goes with 1x. Obviously, it's the square root of 1.3. You could put that in a calculator and see what you guys get. But if you guys wanted to test it out, you graph your derivative test, and again, you pick a number that's less than negative square root of 2, greater than square root of 2, and between 0 as well. And when we plug in value, we get a negative value. So that tells us this is going to be our function is going to be going down. And then if we look at the g prime between 0 and the square root of negative, the square root of 3 over 2, negative, you see that the graph is going up. So that gives us a minimum value, right? And that proves the whole point of we want to get closest to it. And same thing, I'm just going to skip this. You guys could do this on your own. And you see that that's also a min. And exactly that proves that our function, which point? Well, it occurs when x is equal to, the point closest to it is going to be where x is equal to the square root of, negative square root of 2. Actually, I messed that up. You should include, there you go. And now we need to plug that into the function. We need to plug that into our function to see what value we get, all right? So you got to plug it in, 1 minus the square root of 3 over 2. And again, I keep making that mistake. And you end up getting 5/2, okay? So what's going to be our point? It's going to be negative square root of 3 over 2, negative square root of 1.5, and that gives us 5/2. And you're going to get the other point, because it's symmetrical, it's going to be the same one, but this one's going to be on the positive side, okay? And it also renders 5/2. So there you go. That's your answer. It's going to be that point somewhere right there, and it's going to be that point somewhere right there as well, okay? Where the graph is 2.5, and those should be the same distance, and it happens right there, right? That's going to be your minimum values.